and share my screen. I think we stop here, right? The indexing of um, the 1D array and the slicing, right? So basically, the non-py is a library which contains um, many math-related or statistic-related functions, and the centric concept in non-py is this array. So array is similar like a list, but the only thing different is it is more efficient when dealing with a large amount of data, and it has its own implementation in those slicing and lookup, which is more efficient. So as you can see here, we can simply use the index to get certain data from this array. Let's say you have an array, which is a range of numbers starting from 0 and basically you have 5 numbers generated. Also, you want to have this a squared number obtained. So it turns out what you have will be this 5 numbers: 0, 1, 4, 9, 16. So that's the 0 square, 1 square, 2 square, 3 square, and 4 square, right? That's what exactly this line of code does. And once you have this array, you can easily have each of the individual elements in this array. For example, you use this index 2. Turns out you will access this position and get the number 4, right? It's same as the list as well as the string. Also, if you want to just slice a portion of the data from the original array, basically the starting index is 2, that is here, and this will be included. And the end index is 5. Basically, that means the 5 is not included. Means you want to find the position before 5. In this case, it has index 4. So that is this 16. So it turns out you slice out from 4 through 16. Turns out that's the result. Right? That's how you slice the 1D array. And for the 2D one, I don't want to go to too many details. Actually, it has its own rules and ways to slice and access a portion of the 2D array. The only thing I want to point out is, for example, you want to have only the whole row of data like this. Basically, now the array is reshaped like this. It has 2 row and 3 column. And if you use a1, a squared bracket 1, actually it indicates you want to access the row with index 1. So the first row has an index 0 and the second row has an index 1. So basically you want to take the whole row out because A is not a 1D array this time, it's a 2D one. So you are talking about the whole row instead of a specific element. So what if you want to access the specific element in this array? Turns out you want to find out, you want to use 2 index. The first one indicates the this row, and the second one indicates the column. Basically, let's say this A array, actually it represents this kind of matrix or 2D array. So basically this is row 1 and this is row 2. And this is column 1, column 2, and column 3. But remember, for the row index and column index, we still use, they still start with 0. So that means for row 1, the row is index is 0, and the row 2, it's row 2, the row index is still 1. And similarly, the column 1's index is 0, column 2's index is 1, column 3's index is 2. So basically, you just look up these numbers and locate where the element is. So you have A11, that means, oh, well, you have the second row and second column. So that's this 4. So it turns out you get this element by using the 2 index. There are different ways to use the 2 index. For example, like the line 11. Oh, shoot. Basically, it is something like A and 2 bracket 1, 1. Or you could have single bracket, but using comma to separate the 2 index. So this is more preferable because you are saving 2 bracket. That will make it easier and less errors. So that's how you access each individual element in your 2D array. So probably we will not utilize the 2D array that much. Essentially, we can use 1D array to achieve a lot of tasks. Although there are many remaining content in this non-PY, but I would like to stop here. I will post some documents with a more comprehensive introduction to the non-PY and the system PY. By the way, I will skip the system PY because there are too many things. And I believe once you go through the slides, you are able to go through the material yourself. Due to the time limitation, I would like to directly go to the last topics of this class, which is the another 2 library. Let me share my screen again. So these 2 libraries are also very important. Basically, one is called this matplot library, another one called pandas. So these 2, the first one is from the name, you can tell it has a plot. That's a drawing library. It will plot your data and give you different figures when you have a series of data. That's very important because nobody wants to look at, tons of numbers. It doesn't make sense. If you could plot it to a chart or figure, that will be more preferable. That's the function of matplot library. I will go through a simple example and let you understand what is a matplot library. Another one is a pandas. Pandas is specifically for processing those forms or Excel forms or other forms. Basically, it has very powerful functions which will deal with the data in a frame or a form. Let's look at them one by one. So there are multiple ways to do the data plotting and visualizations. We have the matplot library, Seaborn's Bulky, and Plotly, and so on and so forth. Let's focus on one because they are, in terms of function, they're similar. And sorry, once you have some understanding on one library, you could easily pick up others by yourself. So let's focus on this matplot. All right. So again, to utilize a library, you want to import this library as well. At the very beginning. So basically, you want to follow the exact same way like the code listed here. The only thing is you can name it differently. I mean, it's up to you. But once you name it, you want to use a name in your following code, just to make it consist, right? And you can see the simplest function is just plot a few points. So you want to use the figure function. Of course, you want to define the size 5 by 10, 5 by 4 inch. And this is the resolution. If you ever play with different, image, or you set up your LCD or LED screen, you will know this DPI means dot per inch. That represents the resolution of the image, meaning given the same given the same size, how many pixels or dots are here. So basically, the image is like this kind of small grid. Yep, just to bear with my bad drawing, but that gives you some idea of a image. So each of this will be 1 pixel. Of course, and that represents the smallest feature you could represent, you could see on this image. If this DPI is higher, that means for the same length and width, it has more points, more pixels, which means you have a finer resolution, and that will give you the opportunity, the capability to have better, smaller features represented in the image. Of course, you can play with this parameter as well, and also the figure size as well. And you just give this function a series of points, and then you could label the 2 axes, X and Y. If you look at the results, it is it appears like they appear like at these 2 points, right? And then use the show function. And it turns out after you call this show function, it will plot the data for you. Basically, you have 4 points created. And it turns out that's your 4 data point. But also you could plot some functions. For example, if you want to plot a cosine function and a sine function, by the way, I think we didn't introduce these 2 functions, but that's the function method of numpy. I think it's very simple. Basically, that's the cosine and the sine function. It takes some x value and gives you the cosine and the sine value of at that x value. You want to specify what's the value range for x, right? So here, this line space, that's the start. That's the start value, and this is the end value, and this is how many points you want to have within this range, right? That basically at each of the point, this cosine and sine function will be used to evaluate the function value here. Again, the numpy provide this pi and pi value, and basically you can just use it very easy, right? And again, plot this figure out. Also, you want to plot two figures. One is the cosine. 2 curves. One is the cosine, and the second one is sine. And after you set up everything, call the show function, and it turns out you have this value. It's very, it's unsmooth, right? Why? Because there are only 7 points for each of the two curve. If we count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And how about this? 1, 2, 3, 4, 5, 6, 7. Yeah, because during this I mean, in between of this this range, there are only 6 for the apparently this is sine and this is a cosine. There are 6 turnings for the sine and 7 for the cosine. So that's why you have such kind of a shape. And it's not good because, I mean, what we expect are smooth curves like something like this and something like this, right?
Can you do like 100 instead of 7?
Exactly. Yeah,
Okay.
that's what I want to talk about. Yeah, exactly. But actually, how about even more? That's 256. Turns out you will have very smooth curve. See, basically you are dissecting the whole range of values into smaller regions, and it turns out you will have a very smooth curve. So basically, that's the parameters you want to tune. And I will give you more examples to show, okay, how you're gonna play with these parameters and make it a different look. So that's the resolution of the points, right? Of course, you can do something else to change the line patterns and the colors by just simply set up this color and the line width, line style parameters for the plot function. You can have a navy blue like this, and a deep pink for this, and a line width 2 for the for this curve, and a line width 1 for this one, right? Also the line styles. So you can have a dash line by specifying this kind of pattern, and a solid line in this way. So now you could have all different types of these curves just by manipulating, I mean, tuning these parameters. That's the curve line pattern and the colors. Also, you want to set up the limit. Basically, you can set up the X limit and the Y limit. And this is a lower bound and upper bound for X, lower bound for Y, lower bound, I mean, upper bound for Y. But for this one, I mean, it's kind of trivial. But for some other curve, you just want to care about only one portion, a small range. I mean, the curve in a small range. Then you could use this to skip these ones, which you don't care, right? That's how you can do it. And also, you can set up the ticks for X and Y. Basically, this is you are setting up something like this for the Y, and something for this. I mean, like this for the oh shoot, for the X. It's not easy to use the pen. So what you have here is for let's look at this maybe. For the Y, you are looking at -1 to 1, and you have 5 regions for between, I mean, for each of the half range, and that's the value you want to specify. And similar for here, it turns out you will have the ticks for X and Y like this. but it may not be the one you want, because for the cosine and the sine function, probably you only care about 0, 1, -1 for this y value, and for the x, you don't care about these integer numbers. You might only want to check these like pi over 2, -pi over 2, 0, pi over 2, pi, and a negative pi, something like that. You look at these values instead of these positive, negative, integers. So in that sense, you can play with this x tick and the y tick to make it different. So what you could do is, okay, only set up the ticks at these points for the x, and only set up y ticks at these points, at these values. It turns out, well, you have a very good, a better ticks make more sense to you. So you can play with these based on your need, and that's a lot of. That make a lot of sense, more sense to us, right? When checking the cosine and sine function. Of course, there are more functions and ways to draw the curves, and we will go through an example in Thursday's lab session. And that example is very important because it will be directly linked to your final project. So we will read a file from actually an STL file, an X, what's it called? Excel file. Yeah, an Excel file with a lot of data, and extract the useful ones, and do some statistic and draw curves using this library, matplot library. But before that, you want to know another library, that is the pandas. So the pandas is used to handle the data in a form, in a chart. Or so similarly, you want to import the pandas library, like the one showing here, import the num.py and panda.py, and then create a, basically, you can create the index. So one index which are widely used is the data and time index. So this pandas specifically provide the functions to create such a date time index. For example, you can create a series of index by calling this data range function. So this is the starting date and time, and you want to set up a period 10. So 10 what, right? Basically, that means you want to have 10 such date and time, but you want to also specify what are the frequencies in between of the 10 times. You could set up seconds, days, and so on and so forth. And here, you basically this 2s, it's not a 5, it's s, 2s. That means you want these data time to have a 2-second distance. For example, when you call this function, what you have will be something like this. Turns out this is the starting one, and after 2 seconds, you have this time, another 2 seconds, another 2 seconds, and so on and so forth. In total, there are 10 different times, time data index, right? Also, you could set up different frequencies and different date time index. In this case, you only want to have 4, And basically you want to have 4 days, right? You don't care about the exact time, but only the days. So again, starting from this, and what you have will be, okay, January 1st, 2018, and January 2nd, January 3rd, and January 4th, right? This is how you could have a time, I mean, date time index with the distance 1 day. So you might notice, basically these 2 parameters are important for you to create such an index. So what you want to do is you want to see what could be the possibilities. Actually, there are many frequently used letters, like the A represents the year, and M months, W week, D calendar days, B business days means for the business days it will skip Friday, I mean Saturday and Sundays, right? Hours, business hours, minutes, seconds, and milliseconds, so on and so forth. So by setting up your the frequency with these keywords, with these letters, you could set up generate a different set of these datetime index. So what you will utilize this is you can create a so-called data frame using these set date and times. So for example, you can call this data frame function. And turns out you want to generate a kind of form like this. The index are the one you just generated, right? Starting from the January 1st, and you have 4 days. But that is for the rows, right? But how about columns? And you have columns starting. I mean, basically there are 3 columns with the letter A, B, and C. Then in order to fill these cells, right? What you want to do is you want to generate a random matrix or 2D array using the I don't know if you still remember or not, for the non-PY. So this non-PY library can randomly generate matrix or arrays for you. Just call this function and specify the dimension. That's the 4-row and 3-column matrix, which is exact these data. So this is randomly generated values. And once you complete the function call, you will immediately have such a data frame. So how convenient it is, right? You don't need to deal with each of the lines. You just set up all these parameters, you will have something like this. So just imagine if you read the data from a file and you want to create a form, and you can just simply use this, just to replace this part using the data you read instead of randomly generating, right? Sorry. Also for the index, sorry, for the index, you want to give it a name. So you can easily, by calling this function, you can easily have a name called data time. And the result will be like this. You have this part also filled, right? That's how you have the data frame. Also, there's another way to create a data frame using a dictionary. So as you can see here, this dictionary has two key, 1 and 2, and the data for this key are a series. This series is a data data structure of this pandas library. So what you will have will be, okay, you will have it's basically the values here put as the first this is a list, and you put it as the first parameter for the series, and the second one is the index. And it turns out you are linking these two with the column 1 and this to the column 2. So by knowing this, you can easily create this data frame. I mean, the precondition is you have to store your data in this way. Once you store your data in this way, what you have will be, okay, you create two columns, 1 and 2, and the index is A, B, C. And for the first row, you have 1, 2, 3. I mean 1, 2, and no, there's no 3 because you only have 2. And but for the second column, you have T1, T2, T3. So remember this when you call this data frame function, the pandas will read the data you have, and it will compare. Okay, oh, you only have 2 data for this column. I mean, but for this one there are 3. Oh, that means you are missing one. Basically, it will fill this NaN means a null. That means null means nothing. There's something wrong, but it just basically that it just puts nothing here, and this pandas library will recognize this NaN, and it knows there is nothing. But for this second column, you have 3 values here and with 3 indexes. So that's how you have this data frame. This is actually a very important way to create a frame, data frame. Just imagine when you read the file, I don't know you still remember or not, for one of the project, when you read a file, you actually using dictionary, right? Basically you have in the previous project, you have the specific words or keywords or email address as a key, and some of the information associated with the email are the values. So you can easily use that dictionary and create a data frame in this case, right? So we will have more practice in this as well, and in the lab session on Thursday. All right. So once you have the data frame created, you want to look at some of these parts. So one thing you could easily do is when you just call the name of this data frame, you can have the full data frame or full form displayed like this, right? But sometimes you just want to see part of the data, like the top 2 rows. So if you call the head function and specify a number here, it turns out it shows you only the top 2 rows, right? Similarly, if you want, you put the tails and 3 here, so there are the bottom 3 rows displayed. Or you just want to see the index, call the index function, and it will extract all the index and put it into a list. And use the columns function, it will extract all the columns for you. Or you just want to see, you just want to have the values. It will put into a array, a 2D array. Following the order, it is starting the data frame. Right? So it also does some basic statistic for you. If you call this describe function, it will first give you the count, mean, standard deviation, minimum, and what are the top 25, 20, 50, and top 75, and what is the maximum, and so on and so forth. So you will have a small statistic by simply calling this describe function, and it does all this statistic for you. And you could easily sort these data based on the index. For example, if you want to sort the index, means this one, you can specify the axis to be 0. If you put it 1, it will solve based on this columns. But if you put 0 here, you will sort the data according to the index shown here. And you can specify the descending or ascending order. For example, if put ascending force, that means descending. And then it starts with the later date in this case. And accordingly, these data associated with the index will be swapped, will be reordered accordingly as well, right? That's how you can sort it using the index. As I mentioned, if you switch the axis to be 1, and you will sort the data by the columns, just like the one shown here, because you're still using the ascending, right? That will in the reversed order of the alpha beta in this case, right? Sometimes you just want to sort based on the values, but there are many values, right? For example, you want to sort the value in column B, and again, the descending order. And then you will have the maximum, the top is on top, and then the, the maximum, minimum on the top, and the maximum, in this case, is not descending, it's ascending, I'm sorry. So there's a minimum on top and a maximum on the bottom, right? It checks the value in the B column. Basically, you are specifying it, right? So that's how you sort it. So basically, it's not just this value move. It will move the whole rows, but based on this B value. Just to remember this, when it moves top or bottom, it will move the whole row instead of just this specific value, right? And I think that's what you want. Just imagine if you are looking at a let's see, you are looking at a statistic of your final score, right? This is names, and let me make up some. Will, right? Tom, Susan, so on and so forth, right? This is quiz 1. Oh no, quiz 2. Project 1. Let me see. I don't want to make too much. Exam 1. Let's see. something like this, right? And basically, this guy has 5, 3, 2. This quiz 2, 4, 1, maybe 4. Project, let's see, 3.5. Let make it 10 points. Full marks to be 10 points. 8.5, 9.5, 10 exams. Let's make it 20 something, right? 15, 75, 15, something like this. Then the question is, okay, so if you want to have rearrange this form based on the final exams, exam 1, score of exam 1. So what you could do is just sort it by E1, and of course you decide it's ascending or descending, and then you will have the whole forms rearranged based on what you need. That's so convenient, right? And also you want to, for example, you want to sort it based on the alpha beta instead of the scores. Then just use this switches to axis 1, and it will take this index instead of the columns, right? So this is how you can use it. If you look at the Excel, so basically it implements similar functions. But if you use this this library, you could read from files. You could come up with your data by checking files, by searching, by processing some raw data, and then directly output them using this kind of functions and the libraries. All right. So that's just a very simple example. So another one is, oh, I think that's pretty much all I want to cover in the lectures. So there's still a little time, around half an hour. So what I want to ask you to do is, I will upload this lecture notes to Microsis. You want to download it and type this line of code into your Jupyter notebook and do a little practice. Because why I do this? Because I think the time will be quite critical for the live lab sessions if we do not do it before the lab. Because I will introduce even more in the lab sessions, such that you could understand how you use these two library to do some to deal with some real world problems. So that's why I want to leave you a little time, because it's a very intensive lecture, I will say. So in the rest of the lecture, just try this code and understand the functions. All right. Let me do the uploading. Just 1 second. And by the way, I will release all the remaining quiz and also the project 1. I mean, your scores by the this Thursday's lab session. So if you have questions about your quizzes and project 1, you can ask me as well during the labs. And as well as next week's lectures, as I mentioned, that will be a Q&A session. It won't, I mean, I won't teach you more content in the lecture, but it's more like a review and a Q&A session. So I will try to upload it. I think I would say the time is a little critical for us to go over so many content, but I think it's still good enough courses for you to have some understanding of Python programming, and more importantly, there are some contexts, not just the programming language itself, but also I think I give you some, I would say, enough context for the applications of Python. You can download it right now. I just upload it. And I will stay here, and you guys just type the code to the Jupyter Notebook. I would 100% recommend you to do this. Otherwise, you will feel lost for the lab session, because I will introduce more, even more in the lab session. And there won't be enough time for you to practice the lecture we just introduced. All right. Please go ahead and practice. Download the lecture notes and practice. I will be here.
Did you say you want for us to just do the lecture notes 14?
Yeah.
Okay.
Yeah, exactly. Yeah, because I won't have time to let you practice for the lecture 14, and you don't need to submit anything for 14, because basically that's for you to master these foundations. Otherwise, you will feel difficult to understand the content I will give you on the lab session. So I mean, you should practice yourself before that.